Hello students, today we're going to be solving equations. We're going to be focusing on multi-step equations. As always, do not forget to take notes as we go, and at the end make sure you complete the check on the website. So far what we have focused on is one-step equations. In there we only really do one operation at a time, whether it be adding, subtracting, multiplying, and dividing, and our key thought process was to go through and do inverse operations. So we would undo what we had there. Then we moved into two-step equations, and with two-step equations we did two operations. So we had variables typically on one side, and then we did multiplying and an addition, or we do subtraction and division, something like that, but we continue to use our inverse operations. Now we're going to be focusing on multi-step equations. This is when we have two or more operations involved. Also, we can have parentheses in here, and we're going to utilize distribution. We can also have variables on both sides of the equations in these types of equations. So there's a three-step thought process that I want you to think about when you're going through and solving these problems. Your first step is to distribute to eliminate parentheses, and I'm going to review that in a moment. Step 2, you're going to combine like terms on each side of the equal sign. We're also going to review that. And then finally, step 3 would be to solve by using opposite operations. So to review distribution, we get problems that look like this, where there's something on the outside of parentheses and some things inside the parentheses. The way we solve these problems is we're going to distribute through with the 3. So what happens here is we're actually going to multiply 3 times x and 3 times 4. But what we're going to write down is the simplified version of that. 3 and x is just written as 3x. 3 times 4 is just written out as 12, and this would be the simplified version of it. To review combining like terms, if I give you a problem like that, we're going to look for things that look exactly alike. So for example, x and 2x are like terms because they both have x, they have the same exponent, so on and so forth, while the numbers 2 and 3 are alike because they're both constants. They have no variables attached to them. Now sometimes I like to rearrange them so that they are like terms are near each other, so the x and the 2x are next to each other in 2 and 3, and then I just combine them. So x plus 2x, I have 3 x's all together, and 2 plus 3 is 5. So now that we know how to distribute and combine like terms, let's start doing some examples. So here's our first example. As you can see, we have ourselves a set of parentheses with a number on the outside. So what we're going to do is distribute through with this negative 3. Now be very careful with your signs. When I multiply a negative 3 times the positive 3x, I'm going to get a negative 9x. Also, when I distribute a negative 3 with a positive 5, I'm going to get a negative 15. So do you see how that plus sign has now become a minus sign? Now we're moving on to combining like terms since we have no more parentheses. In this problem here, we have the negative 15 and the negative 5, or you can look at it as minus 15 minus 5. So when you're thinking on a number line, negative 15 is somewhere down on the left-hand side of the number line. When I subtract 5, I'm going to go 5 farther back. So when I combine these two like terms, we're going to get a negative 20. Now this becomes a solving equation, a two-step like we did the other day. So I'm going to draw a line down the middle, and I'm going to start working with this negative 20. I'm going to do my adding first. Since this is a minus 20 or a negative, we're going to add that to both sides. So this cancels out, and we're left with a negative 9x on the left. Now we're going to combine our negative 83 plus 20. When we think about that, when we add, we're going to move to the right of a number line. So if we're down at negative 83, when we add 20, we're going to head to the right, and we get back negative 63. Now we're back to our one-step equations like we originally had and started with. So we're going to now divide, because here we have multiplication. So we show division through the fraction bar. We're going to divide both sides by negative 9. Our 9's cancel out, and we're left with x is equal to 7. Do you note how we have a negative and a negative? So since we have an even amount of negatives, we get a positive. For our next example here, we do not have any parentheses, but I do want you to note that we do have variables on both sides of the equation. Now, just like I was able to move my 20 from this side to the right-hand side here, we can do that with variables. As a rule of thumb, I typically try to move either the smaller number towards the bigger number, or I try to make the variables go on the left-hand side. So what I mean by that is, since there's no distributing or there's no parentheses, I'm going right to solving. And now I'm going to move the 6r to the left-hand side and move it with a 7r. So the key thing here is the same as you're doing opposites. This is positive. The opposite of positive is negative. So that what that means is I'm going to subtract 6r so that those cancel. Now on the left-hand side, 7 minus 6 gives us 1r. So now we're left with 1r plus 7 equals 3. Again, we're back to our two-step equations. I'm going to subtract 7 from both sides. Now from here, if I'm at 3 and I subtract 7, I'm going to count to the left. 1, 2, 3, 4, 5, 6, 7. So I know that 1r is equal to negative 4. Now typically we're going to stop at this point, or you can think of it as if we were dividing by 1. But r is equal to negative 4. These are our very special types of equations. So for this one here on the left, what we get is we have parentheses, so we're going to have to distribute through with our negative 3, which results in a negative 15 and a negative 3x. And now once again we have our x's on both sides. We've already taken care of combined like terms and everything like that, but do you see how these x's are the exact same amount? So what happens here is when I do the opposite with my x's, so I do plus 3x, not only does it cancel out on the right hand side, it also cancels on the left. And I'm left with 15 equals negative 21. This is a false statement. This is not allowed. So what that means is your solution is no solution. There are no numbers you can plug in for x that makes the situation true. Let's take a look at another one similar to that. So if I were to go through and distribute, because I have a set of parentheses, I'm going to get 20 minus 5k. And now, once again, I have the 5k's, and they're exactly the same. They have the same sign. They're both minus or negative, and they're both the same number, same variable. So the opposite of subtraction is addition. So I'm going to add 5k to both sides. But once again, they cancel out, and I'm left with 20 equals 20. This is different from the last one because this is a true statement. So for this one, that means all real numbers is the solution. That means any number you plug into k here and you substitute into k here would give you a true answer when you evaluate it. So just to review, you always distribute, combine, and then solve. If you have any questions, please write them down now and bring them to class tomorrow. Also make sure you go to the website and complete the completion form. See you tomorrow.